high-speed optical communication links, non-linearities in optical links, solid terms communication, etc. So now the session is over to you, Dr. Vinita Tiwari.
Thank you, sir. Thank you for the introduction. So I think we should start for today's session.
Yes, ma'am.
Good morning to one and all present here. I hope everyone is doing well at this time of pandemic. So we are starting this presentation of various GPON standards and components. I would briefly introduce why we need all these type of topics at this time specifically. Although data and bandwidth requirement is now a long story, but especially for today's in the pandemic situation, it is more relevant to the society. Because the extensive use of the internet, the demand of high-speed broadband services has increased drastically. Due to the pandemic situation, India's internet consumption rose by 13% since the nationwide lockdown was put in the place to check the spread of COVID-19. According to the Telecom Ministry, that showed that Indians consume 308 petabytes or 308,000 terabytes of daily data on an average for the week beginning from March 22. The daily average consumption in this period was 9% higher than 282 petabyte data used in March 21. The Janata curfew was announced, and the 13% more than March 19. So now, through this data, what I was trying to say that during the 7-8 months, even in India, we are consuming this higher data and higher bandwidth. And this consumption reflected how people are more streaming content and logged from work from home. In fact, this FTP is also going in the online mode, which was also captured in how data demand from residents rose as compared to the commercial areas. An interesting thing is the education field is one of the highest consumable area. I think we all belong to this area, and we are among the highest consumable users. This data and data transfer is only possible when we have fiber from local net. So in today's presentation also, we are trying to emphasize on how this high data demand, how this high bandwidth demand can be achieved. So in this presentation, we are going to cover these topics. What is passive optical networks? And then some evaluation of passive optical, this, and how they are different from active optical networks. Then after that, bitrate enhancement in active and core networks. Because now if we are increasing the bandwidth or if we are increasing the data rate in the core network, then only it's possible for the end user data rate. Then we will come to the GPON, that is gigabit passive optical networks, components of GPON, the standards of PON and GPON, and the recent trends in GPON. So,
participants, please.
Rakesh
Kumar Maurya. Okay. Basundhara.
So due to such extensive uses of internet, the demand for high-speed broadband services has increased drastically. Thus, extensive increase in network traffic and applications has delayed between the users. The passive optical network and fiber to the home or fiber to the premises (FTTP) is used effectively. But to overcome these problems, so I can say that passive optical network is a point-to-multipoint fiber to the premises network architecture in which unpowered optical splitters are used to make a single optical fiber to serve multiple premises, and that is typically around 30 to 128. A passive optical network consists of mainly optical line terminal at the service provider central office or head-end, we can say, and the optical network unit, which is placed at the end user location. This PON configuration basically reduces the amount of fiber from the central office to the end users compared with the point-to-point architecture. And we are using different wavelengths for the upstream and the downstream. So downstream signals are broadcast to each premises sharing a fiber, whereas upstream signals are combined using multiple access protocol, basically TDML and WDML we are using for this transmission. So we can also say that OLTs in PON ranges the ONU in order to provide the time slot assignment for the upstream communication. So in recent years, and practically if I'm saying, today the PON networks point to multi-point fiber technology basically support 1 Gbps to 10 Gbps of data. And the distance which was theoretically 20 kilometers, and nowadays papers are coming which showing that it is around 80 kilometers. So they are not more than a passive nowadays. Active network elements are the optical distribution networks. So main feature of passive optical network is they have no active components. There is no need of the optical to electrical conversion. The only demerit of PON is a small area coverage, which is we are saying is 20 km, 10 to 20 km, based on the services and based on the network provider, which depend on the signal strength. In an active optical networks, the network coverage ranges is around 100 km, but in PON we are saying it's a 20 km. So passive optical networks basically, as we have discussed, is main contents are your optical line terminal, a splitter or combiner, and the optical network unit. The central office has OLT, which link the optical network to the internet protocol, asynchronous transformer, a synchronous optical network that is shown at background. We are saying optical splitter is a passive device that split the single optical signal from OLT into multiple equal but low power signals to ONU, located at the consumer side. The upstream direction is from the multiple ONUs to OLT, and the downstream direction is from OLT to ONUs. This passive optical network has various types, of which is the Ethernet passive optical network, and is one of the type of one. So we can say that this OLT is an ultimate network manager. The traffic is from video, data, and voice signals and send them to the downstream to the OLTs. Whereas the OLT also receive these signals from the end users and OLT and send them on their way to their destination over the internet. To ensure that downstream and upstream signals do not interfere with each other, they are sent on different live wavelengths. The downstream traffic is sent at 1550 nanometer, basically for video, and 1490 nanometer, that is for data and voice. The upstream traffic is sent back at the 1310 nanometer. So this is how we try to avoid the interference between the upstream and downstream systems. Whereas in optical network units, basically there are two nomenclatures, ONT or optical network unit or ONU. ONT is ITU-T term, whereas ON is your IEEE term. They both refer to the end user side equipment in PON and GPON networks. A small difference between them is maybe the application location. This ONU can work in different temperature and weather conditions. The ONT is your optical modem, we can also say, that connect to the opposite end of OLT at the end user resistance. It acts as an interface with the end user's equipment like computer, television, Wi-Fi, VoIP phones, and the data received from the end user is then aggregated, optimized, and sent to the ONT, to the upstream OLT configuration. In GPON networks, ONT can share one fiber connection to the OLT that makes GPON network an attractive option for the service provider wanting to replace the copper network with the fiber. and that is more suitable for the high density urban areas. Now, if we can compare this passive optical network, just we have some introduction notes. What is active optical networks and how they are different from passive and what are their problems? Basically, active optical network refer to the network in the transmission process. Signal adopts photoelectronic conversion devices, active optical assemblies from OLT devices to the end user, distribution and the fiber optic to transmit the active optical assemblies, including the light source, optical receiver, optical transceiver module, optical amplifier, that could be a fiber amplifier and semiconductor amplifiers, and the active optical network. Basically, they belong to the point to multi-point optical communication system, which is composed of ONU, optical remote terminal, OLT, and the optical fiber transmission line. The feature of these compared to your passive optical is that they can provide large transmission capacity, that is around 155 Mbps or 622 Mbps in the access networks if we can talk about, and the long distance, that is around 70 kilometers as we have mentioned in this diagram also, and that is without repeater. In that case, we were saying it's a 20 kilometer. In this case, we are telling it's 70 kilometer. And active networks using the mature technology, that is PDH devices and STH devices, that has been widely used. So basically, we can say that optical networks refer to the conversion between the optical and electrical signal at the input port and the output port, and is always in the form of light in the network transmission and exchange process. Light source is the heart of optical fiber communication. The type of performance of the light source to a large extent determine the type of system, performance, and the cost. That is the reason we are using the different combinations of laser diodes, different structures of laser diodes, so that we can improve our performance and the cost as well as the cost. Now we can say the representative of active optical access network is mainly using the active Ethernet technology. Which talk single fiber bidirectional and point-to-point directly access to the user that greatly improved the bandwidth and the cost also increased. Therefore, the active optical access technology is gradually replaced by passive optical technology. And PON balances out the bandwidth and the cost. Sometimes we need bandwidth. It depends on the application to application and the type of customers we are targeting. So which type of network we are interested in. We should know how to increase or how to improve the data rate capacity of the core network or of the single fiber or multiple fiber, WDM, DWD. Why these concepts are important for us? Because we need high bandwidth to the user end, not at the not till the network to network. So it could be various methods are used to increase the data rate and the capacity of optical fiber, which are used nowadays. That is, one of them is the robust pulse shaping techniques, and one of the such pulse shaping technique is our DO binary. So in this diagram, we can check the spectrum of DO binary pulses, and that will be the RZ and NRZ configuration. We can say that NRZ pulse shape is more robust if you transmit this for the long distance transmission or in the active networks, if we are saying, because they don't have sidebands. So if we have to use all our methods to increase the data rate. It's not just about if we are using the access network or if we are using the WDM. We have to work from the first point, that is starting from the source point, that is starting from the fiber point, then to the, because if our one point is not able to provide you that much bandwidth, then there is no problem, or then there will be a problem of getting the same amount of transmission at the receiver side. So this is one of the method to use the better pulse shaping technique. Another method is the multi-level modulation formats. which are also popular in these days, which can improve the information carrying capacity of optical fiber. And one of such modulation technique is the DQPSK. In this diagram or in this spectrums, we can say that different duty cycles of these RZ DQPSK pulses also have different spectrum. So if we select the different spectrum for different kind of transmission, that will be even beneficial to improve the data. And third, another method is here, and this graph is actually showing the tolerance of those high-speed data links in the presence of non-linearity. In this particular diagram, we are showing that for ACE, for dispersion, for non-linearities, different pulse rate performance. If we have to talk about 100 Gbps and more, the data carrying capacity of the optical channel can be properly utilized. And another method is for this is the polarization state. If we use the both polarization state to transmit the data, otherwise 100 Gbps is just like that, it's not possible. So in this particular analysis, we were transmitting the 112 Gbps per channel in a dual polarized differential quadrature phase shift keying modulation format, and interleaved and symbol aligned and symbol interleaved format. And then we can say that the performance of each of the type of pulse shape is different, and that can be used for long distance high data rate transmission. Another method is our long haul WDM system. So for that, you can say that Soliton is again a good option for long distance without repeater performance to increase the performance. But for that, we can say that we have to manage the dispersion maps. We have to properly manage the dispersion maps, and this is for the stable pulse propagation. And the stability analysis is more important at the transmitter side and similarly at the receiver side. That if pulse are still be detectable at the receiver side, because only the distance is not our concern. Our concern is to get the best BER, best bit error rate or data rate at the receiver side. So these are some of the methods through which we can improve our data rate, and then we can go for the 100G. We can talk about 100 Gbps, even TBPS if we can talk about. These are some of the methods. So what is the difference between active versus, or you can say active and passive optical networks, access network? So this is somehow you can say the summary, that in the active optical networks, ONU devices cascaded in the fiber optic network, and the signal received by each ONU is the signal obtained by the upper ONU. Optical electrical conversion is there. While in the passive optical networks, ONU device connected to the optical fiber network to the optical splitter, and the signal received by ONU is directly sent to the OLT. Another thing which we have seen is how the signal is split between the multiple fibers going to each customer. In active networks, electrically powered devices to direct the appropriate signal only to the relevant customer. Ethernet is commonly used, and the switching devices will typically route this up to 500 customers. Whereas in we can say that splitter enabled in the passive optical OLT port to the signal to the 16 to 255 ONTs and ONU at a time. This active optical network enable the fiber, the last mile, you can properly say that, link to operate over longer distance than the passive networks. This is again, we have seen that this is around 70 to 100 kilometers, which we are saying, and in the passive optical networks, we are saying around 20 kilometers. The troubleshooting and finding a problem is easier with active network than the passive one, because each fiber is carrying signal dedicated to the customer, to the one customer. A1 also don't suffer from the drop in speed as compared to the P1. So speed, if we can say that we initially designed for 100 Gbps, or you can say 100 Gbps, theoretically we can say, but if it falls, then also there is not a drop in the speed. which is possible in case of PON. Active optical network system had an optical interface board with a branch node. To achieve optical direction increases in the network need to add branches. It's a more adaptability, while passive optical network system just need to replace optical splitter and use more shunting optical splitter to increase the optical direction. So passive optical system is more convenient to expand than active optical system, and the investment cost is lower. This cost-wise analysis is always important. As an engineer, we have to provide some kind of low-cost solutions at the customer side. So always we have to take care of about these things as well. Passive optical networks have more reliable protection mechanism than the single node protection. The failure of one node in network doesn't affect the work of the other nodes and have the ability to resist multi-node failure simultaneously. Whole network, we can say protection is there, adopt the same double optical plane protection, provide 1+1 channel protection and 1+1 circuit protection. Now, how to choose which one we can use, passive optical networks or active optical networks? It's all about the services which we are providing, the services we have to deliver to the network. The overall network topology and who will be the primary customer will be. So we can say that if radio frequency video services will be deployed, then PON is typically the only practical solution. If all services are internet protocol based, then however we can use the PON or active networks. If there are longer distance involved and providing power and cooling to the active components in the field could possible, then there will be the active networks. PON may be the all. We can say the target customer is the commercial, or if the project involves multiple dwelling units, then the active network will be the better choice. So basically, we can say that passive optical networks are a better choice for network operators who want to supply a very large number of subscribers, while the active topology or active network is more suitable for private networks that either lay their own fiber optics. So this is how we can select. So this is somehow basic of evolution of our PON networks. That is ATAL passive optical networks, then broadband passive optical networks, Ethernet PON. This EPON and GPON are very much popular and very much compared among themselves for the deployment. Higher bandwidth, this is a larger valuable length package, and the standard for this is ITU G.984. GEPON within the Ethernet gigabyte capability, then LR-PON long range to allow more than 20 km. Approximately theoretically we are saying it's for 100 kilometers. So we can say the GPON and gigabyte passive optical network are the latest and similar familiar one. EPON and GPON are used for the internet access, voice over internet protocol and digital TV, teleconferencing, collaborative gaming, some application used as a backhaul connection for the cellular base station. Wi-Fi hotspot and distribution antenna system, the only difference is the protocol used for the upstream and downstream. The main challenge is in the upstream transmission is the separation of signal from the multiple ONUs, which transmit the signal simultaneously in the combiner. So it must be the multiplexing technique to avoid the collision between the ONU signals. So EPON and GPON, many times, or you can say multiple times, they are compared. So what is GPON? So GPON stands for Gigabit Passive Optical Network. It's a point-to-multipoint access mechanism. Its main characteristic is the use of passive splitters in the fiber distribution network, enabling one signal feeding fiber from the provider's central office to the serve multiple homes and small businesses. So the passive optical as well, this GPON can provide a splitting ratio of 1:64 on the single optical fiber, meaning that the single fiber from the optical line terminal can deliver video, data and voice to the to 64 end user subscribers or the customers. So compared to the standard copper wire in most distribution network, GPON networks are 95% more energy efficient. I believe in this FDP only. There is one more lecture on the energy efficiency and other aspects of GPON, but just I can quote here. And they are economical light signalized for over fiber optic cable as opposed to the electrical signals over copper and coaxial cables. In addition to the efficiency, gigabyte passive optical networks provide a low-cost solution to add new users by using optical splitters, which make it easy to add and manage new customers, making GPON network very desirable in populated areas. So this is the basic building block diagram of GPON. We can then say that the data packets of information at OLT is converted to electrical signal and pass through the fiber, which act as a channel for the electrical signals to pass through the. A passive splitter is used to split the signal to different users at a remote node. This RM you can say the remote node. Splitting of electrical signal make the signal energy attenuate. So there is a restriction to the number of users using single PON, and also as the single energy get attenuated at the bit error rate. Currently, the splitter is made in such that it can provide 1:64 or 128 users. And this figure we can show that GPON technology, since the data of all the users is sent on a single wavelength of light, ONT has to use the filters out to separate out the data from the desired subscriber or the specific subscriber and get their data. So we need to use the filters at the ONT location. And at the ONT, same as we have discussed in PON, is used to electrical signal and convert back to the data and accessed by the end user. FTTH solution is regarded as a fast option with respect to the transmission quality of the bandwidth. The deployment of FTTH, you can say the fiber to the home, access network has gone through a long way before subscribers use fiber cable instead of copper lines to achieve broadband access network. This FTTH is a form of fiber optic communication delivery with fiber extending from central office to the subscriber's line or working space. Home, that means the chiller, home, or you can say the working place. FTTH network can be directly laid by using optical networks or passive optical networks. Both are the options we have to have. And each design offers a way to supply data and its acknowledged intended route to arrive at the proper place. Basically, a GPON can provide downstream speed of around 2.5 Gbps and upstream speed of around 1.2 Gbps. It supports a long distance around 20 kilometers. Unlike copper cable, they have less losses, and the performance of the signal is cannot degrade it because we are using the fiber cable. Standards based and equipment are available from large and growing number of vendors, giving service provider the peace of mind that being logged into a single vendor. That is not the case. Number of vendors are available for this GPON networks. So as we have discussed, upstream and downstream, we are using the different bandwidth and different data. So which kind of multiplexing or which kind of splitters we are using? Here is optical splitter, again an important role in GPON. By allowing a single fiber optic cable to share or split among many end users, optical splitters are installed in each GPON. It's the GPON and OLT and the GPON OLT that OLT serve. Although it should sound simple, splitting level and ratio design must be taken into consideration when designing a GPON network. For example, one optical splitter can provide video, data, and voice services for up to 64 or we can say 128 end user in a number of topographies, including centralized, where one splitter distributes the signals to 64 end users, and cascade splitting, where one splitter distributes the signals to other splitter, which then deliver the signal to the end user. So both ways are possible. So again, we can say that splitter is one of the important and main aspect of our entire GPON service. So how far GPON can move? The distance between the GPON and OLT and the OLT is generally determined by the launch power of the optical transmitter, receiver, sensitivity of the far end receiver, and the optical loss associated with the optical distribution network. In short, we can call them as a ODN. Optical loss come primarily from the connectors, splices, and the splitters. So these parameters, or you can say these components, are very much important for our designing. This total GPON distance is a trade-off between the distance and the split ratio. For instance, if the split ratio is very low, it allows for longer distance as far as you can say the optical limiting. If the split ratio is very high, up to 128 split enabling more subscribers. But we have to compromise between the losses, number of splitting ratio, and the distance. Because our aim is to provide the main data to the subscriber and the end user. With passive optical networks, which is based on time division multiplexing, passive optical network, TDM PON, and the wavelength division multiplexing PON, which is considered to be the next generation passive optical networks. In the present day scenario, access to broadband is increased at rapid pace because of the advantage of fiber, access in terms of capacity and cost. Most of the countries have started deploying GPON. Access is an important part of the national strategy. The PON is promising. It has a few limitations compared to the WDM and the next generation network. It's quite promising unlike GPON because we have large wavelengths available for the transmission. In time division multiple access TDMA based passive optical networks, and dynamic bandwidth allocation, or DBA in short we can call it, is necessary for efficient utilization of the available bandwidth of the upstream link. An efficient dynamic bandwidth allocation scheme can improve the upstream performance of the traffic class of an ONU in two ways. First, it can increase the bandwidth assigned to it by the efficiently utilizing the available bandwidth. And secondly, it can reduce the channel and frame idle time by increasing the polling frequency and by assigning extra surplus bandwidth not used by the other ONUs. Many DPAs or dynamic bandwidth assignments have been deployed or reported by ITU PON, GPON, and the XGPON and IEEE PON, EPON, and 10GB PON, we can also call them. So these are the some of the standards which we were aware of, or we can say that we should look after for the GPON and PON. This G.984 is commonly known as a GPON, gigabit capable passive optical network. It is standard for passive optical network published by ITU-T. It is commonly used to implement the last kilometer or last mile fiber to the home premises FTTP service. GPON puts requirement on the optical medium and the hardware used to access it and define the manner in which the Ethernet frames are converted to an optical signal, as well as the parameters of the signal. The bandwidth of a single connection between the OLT, that is optical line terminal, and the ONT's optical network terminal is 2.4 Gbps down and 1.4 Gbps up. Or late, it's really symmetric, but it is possible that sometimes it is used as 2.4 for both, 2.4 Gbps. Check between the 128 ONTs using the time division multiple access. TDMA protocol. It's a standard defined by GPON specify the protocol for error correction also, that is Reed-Solomon codes, and encryption. AES codes define the protocol for line control on CA, which control the authentication. Through implementation of GPON, there are a lot of common features. Many features were left undefined. Thus, in practice, there is a little compatibility between the various implementation, specifically the exact kind of fiber, cable, and connectors to the undefined. The first version of GPON was ratified in 2003. Since then, it has been extended upon and revised several times. Work on the standards continued. As of July 2018, G984.5 is currently being revised. The most recent version comprises basically 7 parts. G.984.1, this is for general characteristics, was on 2008 with the amendment 1 and 2. G.984.2, physical media deployment PMD layer specification with the amendment 1 and 2, 2006 and 2008. G.984.3, transmission coverage layer specification with an amendment 1, 2 and 3. G.984.4, ONT management and control interfaces ONCI specification with amendment 1, 2, 3. ETRM 1. This is 2009 and 2010 specifically. G.984.5, enhancement band 2014, coexistence with the future WDM PON technology on the same medium. And then G.984.6, its extension, it will actually to increase the extension of the student with amendment 1 and 2. G.984.7, that is for long reach. The GPON OMCI recommendation G.984.4 basically drawn from G.983.2, which define the BPON management model. However, the G.984.4 remove all the references from ATAL, which is again an interesting part. The G.988 is standalone OMCI recommendation and supersedes the G.984.4. Except for the GPON specification that are not defined in G.988. So we were expecting that future work on the PON management model is expected and to appear only in the GPON space. So this is how somehow you can say the global forecast for GPON and how the globally expected or countries are doing for the GPON system. So they can say there rising demand for scalability, mobile backhaul system to fuel this GPON market. This GPON technology is experiencing rapid growth in the adoption of highly scalable telecommunication backhaul infrastructure to address real-time customers' need and amplify market revenue. The rapid emergence of next-generation network includes LTE-A and 5G has pressurized telecom operators to use backhaul equipment flexible enough to address the changing capacity, latency, and the coverage requirement in a dynamic market. This remote access trend and increased digital media consumption due to ongoing COVID-19 breakdown have resulted in a sharp increase in the internet traffic. These telecom enterprises are increasingly emphasizing on providing the continuous delivery of high bandwidth and low latency communication, leading to the positive market growth for the GPON solution. So this diagram also global, what fuels the global market for GPON is. So there is one new numbers. In Spain, the product segment had over 60% GPON market share in 2019, and the growing popularity of high definition, high video streaming, and online gaming access across the country has actually accelerated the demand for optical network terminals. But deploying the ONTs at the end user, they provide the end user device operators can enhance the high definition application in the in their country, basically in their country. Similarly, in the China, the 2.5 GPON market will witness a substantial growth of around 7% during the forecast time of 2.5 GPON in the primary and FTTH technology in the region. Major providers such as China Mobile, China Telecom, and China Unicom rely on the technology for their large-scale residential FTTH deployment. So China, after providing slowing down all over the world, they are improving their data rate by deploying the GPON architecture. Similarly, in the Canada, we can say that the IT and telecom sectors accounted for nearly 50% revenue share in 2019, which is attributed to increased use of smartphones, subscribing using the broadband data services, growing demand for next generation GPON solution for flexible, scalable, affordable mobile backhaul services is a major factor for increasing the demand. This Canadian telecom providers in delivering multiple digital services and adopting the changing market scenario. So we can say that in March 2020, China Telecom invested around USD of 27.8 billion to deploy the 5G infrastructure project to offset the economic impact of the novel coronavirus outbreak in the telecom market. You can say that how much is the impact on our telecom market of this pandemic situation. This industry has also witnessed several strategy alliances between the key players for launching new products with added functionality to maintain the revenue, share, and profitability. So, through these data and these figures, I'm trying to say that nowadays this is not just a theoretical aspect. Countries are deploying their GPON network because even in India we can say that data consumption is increased so much, or requirement is increased because maximum of the companies and maximum of the institutes are working from home mode. So we also desperately need this kind of investment. So in India also, in April 2020, basically Bharti Airtel, which is a leading Indian telecom provider, and the Nokia, they signed the USD of 1 billion agreement for the Link 5G infrastructure in India. This partnership is expected to help Airtel offer stiff competition to major industry rivals through this 5G based services. Some of the key players in this market is our AT&T, Broadcom, Cisco Systems. So this is one of the case study in this slide which I'm going to emphasize on. This is the Cardis Hotel, which is there in the New Zealand. They deployed this GPON LAN or passive LAN in over 400 rooms with a split ratio of around 1:64 with no cables on any floor, fire penetration needed, no room for copper cabling they removed, and they use the predetermined terminated cables for easy of deployment, central management of the system, and future from 20 plus kilometer reach they are targeting. So with this comparison, they are showing that how much space, how much clutter they are removing. So even private sectors or you can say small players or small premises, they are using the passive optical networks to provide the high speed or high internet facilities to their customers. This is the reason network operators are evaluating different alternatives to increase the capacity of their access network as well as the increased reach and fan out. This next generation optical access networks use the technology enabling high access bitrate to any user, but also supporting larger access area served by single access door. This increases the covered area around the reducing the number of access sites, which is expected to reduce the total cost of the ownership of the whole network. Other than GPON, there is a concept called hybrid PON, which has been deployed as many of the most premises. So next generation could be the hybrid, could be the high access, and various TWL, WDE concept to even increase the cost of, you can say, the data rate of the signals, as well as to reduce the overall cost of the system or overall cost of the network. So in this diagram, you can say that if they are using the passive line, their distribution switches are, and if they are using the copper wires, then how much is the square dive, or you can say how much is the area they are saving. Some of the case studies we have quoted here. So I'm ending my presentation here. Thank you so much for your kind attention. We can have some discussion if any questions or inquiries, because I always believe in faculty development program is different from class, or you can say class teaching. This is how we learn from each other. This is not if I'm going to speak and I'm telling you this uttermost truth. If some people are doing their research, or maybe they are trying to do in this area, they are working in this area, they can also share their thoughts in this domain. So it's the open for everyone. They can share their views, their ideas if they have in this domain.
Yes, participants, please. So may we know how many of you are working recently in optical networks? How many participants are working in this area? Participants, please, one by one.
If they are doing some PhD research, or maybe if they are planning to do any research. I think
Prajakta Kanase, you're working in OWC, Optical Wireless Communication, right?
Yes, sir.
Yes.
Okay, so can you discuss something to other participants, or can you tell about
your experiences in this area, how you are working?
Actually, I am a research scholar pursuing my PhD. And my
where?
topic is, am I audible?
Yes, you are audible. You are pursuing PhD from where?
From Swami Ramananda Tirth Marathwada University, Nanded, Maharashtra.
Okay.
And my topic is improvement in the performance of Li-Fi enabled network, Li-Fi based network.
Okay.
So actually, I am performing, means currently the scenario is we are using the Wi-Fi. If in the indoor communication, if we go for Li-Fi, then might be in cases of opaque objects, like if in between the sender and receiver, if any opaque object comes in between, then we can face the shadowing effect. So to remove that shadowing effect, I am trying the hybrid combination of Li-Fi Wi-Fi in indoor network. And for that, access point selection and energy efficiency, these are the two things I'm basically dealing with.
Okay, yeah, because in Wi-Fi, I think one of the issues is the obstacles. If some obstacle is there, then the total signal will drop.
Yeah. So to remove or to take this concern, that is data should be means data loss should be neglected. Data loss should be minimum. That is one thing. So I am going to see the machine learning algorithm in selecting access points so that the losses will be minimum. So I'm currently working on reinforcement learning
Okay.
algorithm in machine learning to select the access points. So by giving the user satisfaction and throughput, these are the two things I am mainly dealing with. So by
Okay.
considering these two
It's
issues,
very good that you are using the machine learning concept in this, because
yeah,
next
actually,
generation is all about AI and machine learning.
yes,
In
yes,
optical also we have to include that, so that we can be a parallel with the technologies which we have come up with.
yes.
So please
Okay. Anyone
continue
else?
sharing your thoughts. Anyone else is there who can share their thoughts on working, how their experience, because we all are from the same type of community. If we discuss our ideas here, we can get maybe some kind of help. I believe after discussion also we can get some ideas. So sharing is always good among you.
Okay. So any particular question from the participant?
I think many of them are sending messages, but I think
I think
it's
it's okay.
difficult to
So
speak out.
I'd like to thank Dr. Vinita Tiwari for giving such a wonderful and nice presentation on various GPON standards and components, etc. So now we'll have another section from Dr. Vinita Tiwari at 12, that is on WDM concepts for high-speed access network. Okay, so thank you all, and thank you, Dr. Vinita Tiwari, once again, and we will start the another session at 12. Okay, thank you.
Thank you all the participants, and thank you for sharing your thoughts, Prajakta. And I think they are asking sir WhatsApp group, and I think slides they need. So we definitely share with this
Okay,
for all those sessions. I've seen in the messages. Thank you all of you.
okay, thank you.